So this is the 5th video in the A2 chemistry rates or kinetics topic. This one we're going to have a look at how do we work out a mechanism based on a rate equation and a stoichiometric equation, so the balance symbol equation in other words. So you're going to take the rate equation, we're going to take the balance symbol equation, and from that your job is to deduce a mechanism. So if we look at this example to begin with, we've been asked in this question, okay, to work out or suggest a mechanism. We have been given some information in the question, really important, we pick up on it. We've got the balance symbol equation and we've got the rate equation. And we're going to write for this a two-step mechanism, okay? So we're going to write a first step, we're going to write a second step. We're going to say that the first step is the rate determining step, and the rate determining step is the slow step. Now, if you think about it, the only substances that should be in the rate determining step or the slow step are the things that control the rate, of course. And the things which control the rate, the species that control the rate, are those that are in the rate equation, because you've already established through experimentation that anything that is in that rate equation must have an influence on the rate. So therefore, it must be involved in the slow step. So therefore, in this one, we know that the only species that is involved in the slow step must be nitrogen dioxide, NO2. So if we go up to the equation up above, we can see that in the equation up above, we have NO2, but we also have carbon monoxide. So carbon monoxide may well be in the balance symbol equation, but we can deduce that it is not in the slow step of this particular reaction or mechanism. Now, we also see that NO2 is second order, and that tells us that there must be two particles of NO2 involved in the slow or the rate determining step. Okay, so that's the information that we can take from the rate equation and how we can tie in the rate equation with the rate determining step or the slow step of the mechanism. Now, we've got to work out what's made here. So if we go up to the equation up above, we can see that there is nitrogen monoxide made as a product. So it would seem sensible to make our nitrogen monoxide at this point. Now, we also see that carbon dioxide is a product up above in the equation, but of course, there is no point in making carbon dioxide here because we have no carbon dioxide or any carbon at all on the left-hand side of the equation. So we'll have to leave that to a later step. Now, the question is then, well, what are we going to make in this particular step? Okay, well, we can essentially make anything we want, provided it balances out with the number of nitrogens and oxygens on the other side. So I can see here that I have one nitrogen missing, okay, and I can see here that I have 3 oxygen missing. So I could make NO3. I could alternatively, if I wanted, make half N2, okay, and I could make 1.5 O2. Either would be absolutely fine. Now, what wouldn't be fine was if I just wrote, instead of writing half N2, if I just wrote N on its own. All right, that is not allowed. You have to write them in their standard form. Okay, so for example, nitrogen is diatomic, so we definitely can't write that. So I'm going to write NO3. Okay, now you might be going at this point, well, hold on a second. There's no NO3 made in the equation up above. That's fine. I'm going to take my NO3 and I'm going to put it into my second step, which means, yes, I made it in my first step, but now I'm going to use it up again, so therefore there would be no reason why it would be in the balance symbol equation up above. So this time I'm now into my second step, which is the fast step. I have my carbon monoxide from up above, which has to come into play this time. Okay, and what am I going to make this time? Well, up in the equation, you can see here we have reacted 1 NO2, but based on the rate equation, I've had to react 2 NO2s down here. That means I have, in order for everything to balance up, I have to produce, reform, whatever you want, another NO2. That means net only one nitrogen dioxide or one NO2 has actually reacted. But I still must react 2 of them in the slow step because the rate equation tells me that I have to. Okay. Now you'll notice up here we've got carbon dioxide made, okay, and you'll notice rather conveniently down here to balance this out, I need to make carbon dioxide. So let's just go through and check it. Everything tallies up with the rate equation and the balance symbol equation. So the rate equation means that I have to have 2 nitrogen dioxides in the slow step. I do. Perfect. Done. Okay. I have to overall make 1 nitrogen monoxide. I have overall made only 1 nitrogen monoxide in that step. Doesn't matter what step it's made in. Okay. I have to overall react only 1 nitrogen dioxide. I've reacted 2 in the slow step, but I've regenerated 1 in the fast step. That's fine, that tallies up perfectly. I have to react 1 carbon monoxide, and it has to be in the fast step. Done. I have to make 1 carbon dioxide, sorry. It's done. I've made a nitrogen trioxide here, okay, but I've used it up here, so there would be no reason why it would be in the slow step, or sorry, in the balance symbol equation. So that is your answer to that one. I'm going to put up the next one on the board here. You can have a go at it. So really, it's part C is the question. It's very similar to the last one. Okay. So maybe you want to pause the video and have a go at that. We're going to suggest a 2-step mechanism. We'll say again that the first step will make the first step the slow one, and we'll make the second step the fast one. So I'll do it here now. You can pause the video, have a go at it yourself. So the slow step has to be 2 NOs, because NO is in the rate equation, second order. I'm going to make, well, I have to make nitrogen dioxide, so it would make sense to make nitrogen dioxide in that step. That leaves me with 1 nitrogen left over. Remember, I can't write N on its own. It has to be half N2. Okay, now there's no nitrogen made in this overall equation, so I'm going to have to take my nitrogen from up here, and it has to be used. I have oxygen here, which is not in the slow step. It has to be in the fast step, so we're going to have to put that in there. And I've got to make another NO2. Okay, so if we look at it, I have 2 NOs in the slow step. Yep, I do. I have made 1 nitrogen dioxide. I've made 1 here, and I've made another one here. So there's 2 of those have been made total. I have made a nitrogen molecule, half a nitrogen molecule here, but I've reused it, so it would not appear in the equation. I have reacted 1 oxygen. Okay, in total, it's not in the slow step. It's in the fast step. There you go. That is your answer. Okay, so we're going to go through a series of past paper questions here. Hopefully, most of them you will find fairly straightforward at this point. So again, pause the video, do them. If you can't do them, switch the video back on again and I will talk you through them. So here we have the balance symbol equation. Here we have the rate equation. We've been asked to put forward a 2-step mechanism for that. Okay, and it says the first step is the slow step. So let's go step 1 here, slow step. That has to have 1 hydrogen in it, and it has to have 2 nitrogen monoxides in it, because nitrogen monoxide is second order. Up here I've got to make nitrogen gas. Well, I can make it here. I have my N2, so let's just make it. Okay, and I've got to make some water over here as well. Do I have enough left to make water? Yep, I do. Okay. Now that means I've used my 2 hydrogens here. I've used my 2 nitrogen, but I've only used 1 oxygen, so I have to remember to bring my oxygen through. And I can't write O on its own. It's got to be half O2. Okay, so so far we have reacted 1 hydrogen, and so that was in the slow step, just remember. We have to react 2 hydrogens in total, so I've got another hydrogen that I've got to react here. Okay, I have got another water molecule that I have to make as well, because I've only made 1 water molecule so far, and there's 2 in the balance symbol equation, so I need water there. If you look, I have this oxygen here, and I have to reuse that oxygen because it's not in the balance symbol equation as a product, so it has to be reused, and that balances out perfectly. So let's just double check. Slow step, 1 nitrogen, 2 nitrogen monoxide, 1 hydrogen, 2 nitrogen monoxides. Yep. Have I made enough nitrogens? I've made 1 nitrogen, which tallies up with the equation up here. Have I made 2 waters? Yes, I've made 1 here and I've made 1 here. Have I reacted 2 molecules of hydrogen? Yes, 1 in the slow and 1 in the fast. I have made O2 here, but I have used it up, which is spot on. So everything tallies up with the rate equation and with the balance symbol equation. Therefore, that is your answer. Same thing again, guys, just pause the video, have a look at it, see if you can do it yourself. So we've got a two-step mechanism, and the first step it tells me is the rate determining step. So I take my rate equation, species, and I react them together, okay? What am I making up above? Well, I've got to make HCl. I can make HCl here, okay? And what have I got left over? I've got one hydrogen left over, and I've got one iodine left over. Now the temptation, because I've got to make iodine up here, the temptation here might be to go half H2 plus half I2. Do not do that, because that means you have hydrogen here and hydrogen on the right hand side. You're absolutely not allowed to do that. They would cancel each other out. Okay, so you cannot do that. It might be convenient to do that this time, but it will not get you your marks, I'm afraid. So what am I going to do? Well, I'm just going to make HI, and we'll see where we'll see where that takes us. Okay, so that's everything I think is balanced up in there. We move on to the next step. So I've got another ICl, which I have to react in there. I have this HI, which is not in the balance symbol equation, so it's going to have to get removed. Let's see where that brings us to. I can now make my second HCl, which I need to balance out the equation. And I can also make, I have two iodines left over, I can make my I2. Perfect. So have I got in my slow step or my rate determining step one hydrogen, one ICl? Yes, I do. Okay, have I overall reacted just one hydrogen? Yes, I have. Have I overall reacted two iodine monochloride? Yes, I have. Have I made two HCls? Yes, I have. Have I made one molecule of iodine? Yes, I have. I did make HI there, but I used it up, so that's fine. Okay, let's have a look at this one. So this one's slightly different in that we've got to work out what is actually going on, or a step that is missing based on what we have up here. So let's have a go at that. Okay, so if we look at this, we have up above two NOs, so they're both reacted, so that's fine, they're gone. Okay, this has been made as an intermediate, but is used up there, so that's okay, don't need to worry about that. I have one hydrogen here, but I need two hydrogens in total to be reacted, so I have to put a hydrogen into my third step. I have made N2O in my second step as a product. There's no N2O as a product up here, so that has to be used up down below. Okay, I have so far not made any of my N2, my nitrogen, in any of the first or second steps, so I've got to make my nitrogen here, which is fine, I've done that. Okay, and I have to make a second water molecule because I've only made one water molecule so far, and I have two hydrogens and one oxygen to allow me to do that there. Okay? Okay, so if we look at this one, right, so the first thing we had to do here was to work out the rate equation. So I just took experiment 1 and 2 where the iron 3 changed only and the iodide didn't change. So the iron 3 doubled, the rate doubled, so iron 3 is first order. Then I took experiment 1 and 3 where iron 3 remains constant, iodide doubles, the rate goes up by a factor of 4 from number 1 to number 3, so iodide ions are second order. Okay, so therefore I had to now suggest a two-step mechanism. It doesn't tell me which step is fast or slow, so I've just decided the first step is the slow step. I have to have one iron 3 and two iodides in it, so there we go, one iron 3 and two iodides. I can make here now my iodine because I've got iodine to be made, and I can make an iron 2 here as well. Okay. And now here's the one that's something that's slightly different here. Remember, in all of your reactions, charges must also balance out. So up here I have on the left hand side of the slow step I have +1 charge, 3 plus and 2 negatives, +1. Over here if I just stopped at this point I would only have iron 2 plus. Now that does not balance the charges out, so I must have an electron here as well that's been produced. Okay, now of course there's no electrons in the overall equation, so that electron has to be reused. So if I bring that in, I have a second iron 3 that I need to react over here from the balance symbol equation. So I put my second iron 3 plus ion into the fast step. I bring my electron down what was produced in the slow step, and I produce my other iron 2, okay? So everything tallies up. I have 1 iron 3 in the slow step, 2 iodide, sorry, in the slow step. I have 1 iron 3 in the fast step. I have made an electron in the slow step, but I've reused it, so it won't be in the balanced equation. It isn't in the balanced equation, as you can see. I've made overall 2 iron 2s, and I've made overall 1 iodine. So that is your answer. A little bit trickier, that one, because of the charges. Hopefully you picked up on it. Okay, if not, you'll know about it for next time. Okay, again, have a look at this one. Okay, try it. Okay, and if you can't do it, hit play, or if you want to check your answer, hit play. Okay, so once again, there was something in this one about charges that you had to be alert on. So first step is the slow step, the rate determining step. So I had to have 1 S2O32 minus 1000 sulfate ion in there, and I could make my sulfur. I thought it was a good idea to make my sulfur up there and my sulfur dioxide in here. That left me with an oxygen left over and a -2 charge left over, because I have to balance the charges, so I put an oxide ion in there. In my second step, okay, I have to use up that oxide ion because it's not in the balanced symbol equation, as you can see. There are 2 hydrogen ions in the balanced symbol equation which haven't been used in the rate determining step, so they have to be used in the second fast step. So 2 H pluses plus my O2 negative from my oxide ion up from up there allows me to make my water. My charges on the left balance out, my charges on the right balance out. That is your answer. Again, another tricky one, okay, with charges involved and an oxide ion that maybe some of you might not have picked up on. So again, if you did, well done. If not, you will hopefully know for next time. Again, pause the video, have a go at this one, see what you think. Okay, so this one is actually identical to one that I did earlier. Okay, for my example, so some of you might have picked up on that. Right, so I've got 2 NO2. I'm going to make my nitrogen monoxide on the right hand side here. I can either make half N2 or 1.5 O2 to balance out the missing nitrogens and oxygens, or I can just put NO3 in, nitrogen trioxide. Nitrogen trioxide is not made in the equation, so I'm going to take my nitrogen trioxide and reuse it. I've got to react it with a carbon monoxide from the equation, because there's carbon monoxide in the equation, but not in the slow step. Okay, that allows me to make my carbon dioxide. If you look at the reaction, the equation overall, I've only reacted 1 nitrogen dioxide. I've had to react 2 because that's dictated by the rate equation here. So I have to regenerate a nitrogen dioxide down here on the right hand side, and I can make my carbon dioxide. That is your answer. Okay, this one's slightly different again. Have a look at this one, see what you think. Okay, so for this one, then we have got our slow step is step 1. We have 2 NOs in it and 1 H2, so that's fine, got those in. I have this N2O here, which must have come from here. Okay, it's because it's a reaction between NO and H2, so this is not a reactant. Okay, so it has to have formed in the first step. So I'm forming it here, and then I'm using it up here. And I've got left over, I have some water. So I'm just going to make water. I think that's fine. You could have actually other answers, but I think water is the most sensible thing there. My N2O from the first step is used up in the second step, so we'll put next through that. Okay, and then I have hydrogen making another nitrogen and another water. So overall, if I add everything up, I have so far reacted 2 NOs. There we go, they're in. I have reacted 1 hydrogen there and 1 hydrogen there. Neither of them have been regenerated, so there are 2 hydrogens net. I have made 1 molecule of nitrogen there, and 1 molecule of nitrogen is accounted for, and I have made 1 water in step 1, 1 water in step 2. That is my overall equation. Hopefully you got that right. Again, slightly different variation on the theme of the question, but nothing too difficult, I don't think. Okay, this question here, I probably would count this as the trickiest of the lot of these. So pause the video again, have a look at it. I think it's the last question on the PowerPoint here. I usually leave this one to the end. Let me just check. Yeah, it indeed is the last one. Okay, so pause the video, have a look, have a go at it. If you can do this one, you will have no problems with what comes your way in an exam. Okay, so let's have a look at this one. This one is definitely the trickiest of the lot. Right, we'll have a look at why. So the first step it tells me up here is the hopefully you picked up on that is the rate determining step is the first step. There's my rate equation here. So that has to be hydrogen peroxide and iodide ions goes to, and I just went to water. And here was the difficult part. If I look in step 3, I have in step 3 an HIO. Okay. Now there is no HIO as a reactant anywhere, so I'm going to have to make that HIO by the time I get to step 3. So what I did was I made an IO negative here. Okay, remember your charges have to balance out, and I have an iodine left over and I have an oxygen left over. That means now in the second step I can bring in my hydrogen ion from up here and I can react it with the IO minus to make my HIO. Now my HIO has to be made, okay, because it is not, as I said, a reactant in the equation up here, so it had to be made as an intermediate somewhere along the line. My third step is given to me. My fourth step then is pretty straightforward because my hydroxide ion that is here is not a product, so it has to be used up. I have only used up one hydrogen ion so far, so I have to bring a second hydrogen ion in here. I have only made one water molecule out of the 2 water molecules I have to make, so that tidied that up very nicely in that I had to make my 1 water molecule. Okay, hopefully you made a decent fist of that last one. As I said, that is the trickiest one, and if you got it right, well done. Okay, you should have no problems with what's going to come your way if you get any questions like this. Okay guys, hope that tidies all that up, okay, and you find that helpful. Any questions, come and see me.